Hey guys, so in this video I am going over 1.2, and on this video I am going to go over graphing and translating quadratic functions. So first we're going to go over vocab. If I go too fast, please pause the video. So the vertex is the point on a parabola that is the max or the min. The max is the largest y value of a quadratic equation, and the min is the smallest y value. The domain of a function is all input values that satisfy the function without restriction. The parent equation of all quadratic functions is y equals x squared. When a quadratic function does not have a specific interval and is not an application of a real-world situation, its domain is always y equals negative infinity to positive infinity. A function is forgot the range, my bad. So range is the output, aka the y values. A function is increasing when its graph rises as it goes from left to right. The function is decreasing when its graph falls as it goes from left to right. So the very first part, only looking at this part here, it is increasing. Next little part, going down, going down, going down. This part is decreasing. And then that last little part, reading left to right, it is increasing. So the slope will tell us whether the graph is increasing or decreasing. We use only interval notation. When identifying the intervals. So for example, we've got this equation here. For me, I'm going to use Desmos to type it in. And we've got y equals 3x squared. So from this, we can graph on our notes. So I can hit the graph, have my gray dot, so 0, 0. And then I can drag my finger if I'm on a phone or iPad, or I can use my mouse to drag on top of the graph itself or the line. And let's see, what kind of numbers are we working with? Okay. So let's try to find a whole numbers for our ordered pair. -2, 12. So we've got 0, 0. We got -2, 12. So that is our graph. No, it does not have to be perfect. Another point, if you want to go back and look, is at 2, +12. So our vertex is where the graph changes directions. What do I mean by this? If I start left to right, I'm going down, 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 down. Then all of a sudden I change directions and start going up. So at that point is my vertex. So it's at 0, 0. Now, little trick. Whatever this x value is your x value for your line of symmetry. For your x-intercepts, well, the x-axis is there. The only time it touches that x-axis is at 0, 0. Your y-intercept, find your y-axis. Only time it hits your y-axis is also at 0, 0. So let me erase some of this stuff for us. We don't want the red one anymore. So back to our graph, our initial graph. We want our domain. So all x values, well, we're going to keep going all the way to the left, all the way to the right. So our domain is negative infinity to positive infinity. Our range, lowest y value is at 0, and it is included, so we're going to have a little bracket. And we're going to go all the way up forever and ever and ever, so we got positive infinity. Now, do we have a max or a min? Can we pinpoint our lowest point on our graph? Yes, we can pinpoint. This right here is our lowest point on our graph, and it is at 0, 0. And that is a min. Next question, can we pinpoint our highest point? No, this graph keeps going up forever and ever and ever. So we cannot pinpoint it, so we do not have a max in this case. So when are we increasing? What is our interval for our increase in our graph? So is it option 1 on this side of the graph or option 2 on this side of the graph? Option 2, it's on the right side of our graph. So we're going to start at our 0, and we're going to go to the right forever and ever and ever. And that is our interval of increase. Now what about decrease? Well, going left to right, we are decreasing from negative infinity to 0. And that is our example 1. For example 2, I want you to pause the video and attempt example 2 by yourself. So you should have gotten a graph that looks similar to this. You should have 2, 4, and 6, 4. Your vertex should be 4, 1. X equals 4. There are no x-intercepts because it does not touch the x-axis. Y-intercept should be 0, 33. Domain, another trick of the trade is that your domain is always negative infinity to positive infinity, as long as you're not under restrictions of the real world, aka a word problem. Your range is 1 to positive infinity. In this case, you do have a min again. 4, 1. Increasing, starting at 4, going to the right forever and ever and ever. Decrease, negative infinity to positive 4. So there is your example 2. Example 3. Once you put it into Desmos, your graph should look similar to this. You do go off the graph a little, but it should be about negative 3 point off a little bit from the 0.5. So let's go right about here. Then you've got negative 5, 3. you've got -2, -3. This is what your graph should look like. So your vertex, so it's our negative, again you can get this from Desmos, -3.5 to 6.25. Whatever that x value is going to be that line of symmetry. Yes, you have to put that x equals part, because if you just put -3.5, that's just a number. That x equals part makes it a line of symmetry, an actual line on the graph. Our x-intercepts, just plugging it into Desmos and finding them. -6, 0. -1, 0. Y-intercepts, 0, -6. Domain, not under any restriction, so your domain should be -infinity to +infinity. Range, we're going to start at -infinity because it keeps on going down forever and ever and ever. Our top y value, or biggest y value involved, is 6.25. In this case, we cannot pinpoint our lowest point because it keeps on going down forever and ever and ever. Our top point, however, we can pinpoint. It's right here. So we do have a maximum in this case, not a minimum. Our max is located at -3.5 and 6.25. Our increasing interval starts from the left, so -infinity, and ends at -3.5, and that's the x value. Starting where x is -3.5 and moving to the right, we are decreasing, moving to the right forever. So that's why it's positive infinity. So pause your video and attempt number 3, or example 3. Example 4, my bad. So your graph should have looked similar to this. So your vertex should be at 0, 0. Our line of symmetry should be x equals 0. X-intercept, 0, 0. Y-intercept, 0, 0. Domain, always. Range, -infinity to 0. In this case, it is opening down, so we have a maximum, not a minimum. It's located at 0, 0. For increasing, we've got -infinity to 0. And we've got 0 to +infinity for decreasing. So the rest of 1.2 is translating quadratic functions. So if we had the parent function y equals x squared, if we went into our calculator, or we went into Desmos and looked at this. So let's go to Desmos, go over here and type in our parent function, y equals x squared. We find our ordered pairs by dragging our finger on the line or dragging our mouse on the line. So that's how we're getting our ordered pairs. We have 4, 1, 0, 1, and 4. And it would look something similar to this right here. For number 2, if we had a negative x squared, we would be working with the ordered pairs -2, -4, -1, -1, 0, 1, -1, 2, -4. So a little bit of vocabulary, a little bit of review as well. For your quadratic function, for quadratics, y equals ax squared plus bx plus c. It's called a parabola. Don't ask where I got that b from. Parabola. So every parabola is U-shaped, whether it is a open upward U or a right side up U or a upside down U. If the leading coefficient, or A, is positive, you will be opening up. If the A is negative, you'll be facing down for your U. Again, the vertex is the highest or lowest point on the parabola. If the parabola is opening up, you will have a min, or minimum. If it is opening down, you will have a max. The value of A in a quadratic equation not only determines which direction a parabola opens, but also the width of it. For example, instead of y equals x squared, if it is a positive 2, it will look more like this. If we have a negative 3, instead of a y equals x squared, it will look like this. So given these equations, determine if it is opening up or down. So this one, A is positive, so we got up. A is positive, up. A is negative, down. A is negative, down. A is negative, down. Oh, and I did the mistake that I was trying to make sure you guys didn't do. So don't do it too quickly that you just make the mistake that I just made. A is always attached to x squared. So if A is attached to x squared in number 5, x squared is all the way over here. So the A is positive. And then the x squared in number 6 is negative, so it's down. Another review a little bit, min or max, so we can pinpoint our smallest point. So we have a min, it's at negative 2, 2, 3, 4, 5, negative 5. Domain, all quadratics have a domain of negative infinity to positive infinity, unless it's under real life restrictions, aka it's coming from a word problem. Range, our smallest y value involved, is down here at 5, negative 5, and it's going to go up forever, so it's positive infinity. And then your vertex, little trick, your vertex and your min and max are always the same. It's that point where it changes directions. So pause the video and attempt number 2 as a review. You should have gotten max to 0. Domain should be negative infinity to positive infinity. Range, negative infinity to 0. And vertex to 0. Moving on. So, line of symmetry. We've already talked about this. So, if you want to, you can pause the video and see if you get them right. We're going to use Desmos to find our line of symmetry. So we're going to come come in here and type our equation in. So y equals x squared plus 3x plus 4. Our line of symmetry, or our vertex, is going to be at that point, which is negative 1.5, 1.75. So just a note, your vertex was at negative 1.5 and positive 1.75. So your line of symmetry, whatever that x value is from your vertex, it's going to be the same. Domain, always the same. And your range is that 1.75 to positive infinity. So you can go through these, but I want to go ahead and get us to the translating part. So if a is greater than 1, and what these absolute value bars mean. So if I had 2, y equals 2x squared. That means that we would have absolute value bars of 2 greater than 1, which is the same thing as 2 greater than 1. Yes, it is greater than 1, so we are going to be narrower or skinnier or stretch. Another example, if we had y equals negative 4x squared. That means we would do absolute value bars of negative 4, and we want it greater than 1. Well, absolute value of negative 4 is positive 4. 4 greater than 1, yes, so it would be a stretch, or it would be narrower, or it would be skinnier. Now, wider. Wider is absolute value of a is smaller than 1. So let's have y equals 1/2 x squared. Well, our a is 1/2, so absolute value of 1/2 is smaller than 1. Yes, it is. So it's the same thing as saying 1/2 smaller than 1. Yes, so it would be wider, or it would be a compressed situation. So let's go through these examples. If we had y equals, or f of x equals, negative 2x squared, or negative 2, absolute value bars of negative 2 is just 2. Is 2 greater than or less than 1? It's greater than, so it's going to get narrower. 1/3 is less than 1, so it's going to get wider. So this one's greater, narrower, and 0.2 is wider because it's smaller than 1. Alright, so if we look at our C, yes, it says K there, but if we look at our y equals x, or ax squared plus bx plus c. C is going to be that one that doesn't have a variable attached to it. That's what it's talking about. It is either going to shift us up, or shift us down. So if x is positive, meaning it is greater than 0, then we're going to go up. If our k or our c is negative, we're going to be going down. So in number 1, we have a plus 3. And it is not with the x. It is outside of the x. And you'll see what I'm talking about in a second. It's on the outside. So our K or a C is positive, so we're going to be shifting up. So let's look at another one. Our -2. Our -2 is on the outside. It's not with the X. So it is going to be shifting down. Now what if it is on the inside? Inside with the X is our H. So this is opposite of what you think. So if H is less than 1, it is going to be going to the left. If it is greater than 1, it is going to be going to the right. So let's look at this. We have -7. Well, if you look up here, we're only looking at H. So what is H in number 1? H in number 1 is +7. So +7 is greater than 1. That means we are going to move to the right. Let's look at another example. Our H is as if it was written X minus H squared. So that means what number do we have to substitute in for H to make it +2? So what do we have to substitute in here to make it +2? Well, we have to substitute in -2. So that means our H is -2. -2, is it greater than or less than 1? Less than 1. So we're going to be moving to the left. So that is how our transformations are going to work. During my live session, I am going to go over a little saying that you can say each time you do these so you can remember how these move.